Hi, everyone. I'm Jaime from Shopify. And this is going to be a little bit of a different talk from maybe the talks that you've heard here. I'm the lead of our engineering communications team, and I work very closely with our production engineers. Many people, when they think of the idea of communications, can see it as fluff or maybe spin, which, to be honest, sometimes it is. But it also plays a vital role because it's the framework for how we as humans, as social creatures, interact and align. If you've ever been to a wedding and heard a very, very bad wedding speech, you can know how important good comms can be. And if you have a small team, a team that can fit inside of a meeting room or two, it's quite simple to get everyone on the same page. You can just have everyone around the table and you can all agree on something. But it becomes much harder as your teams get larger. The complexity grows exponentially, and you have to start intentionally baking in communications. I like to think of it as a lubricant because it reduces friction and it increases speed for your ideas to go to completion. At Shopify, my team works to ensure that our fast-growing teams share knowledge, dispel confusion, and prevent siloing. And building a culture of communications helps our teams scale and become more resilient. So what does a culture of communication look like? Well, for us, it's a series of rituals and routines we've built to affirm a set of values around how we interact with one another. And here are 6 things that we're seeing from fostering this culture. It's a very GIF-heavy presentation. So the first one is it better cross-pollinates ideas. Our production engineers are spread across several continents. And even when we're all in the same office, siloing can occur. We can be on different floors, different teams. We aren't always speaking to one another. And that's why it's really important that 4 to 5 times a year, we bring everyone all together into the same event. We have summits, and we have hack days, which is our internal hackathon. And what we're trying to do there is we're trying to nudge people into sharing, ooh, I feel like I just got louder. We're trying to nudge people into sharing approaches and experiences with one another. That's actually a great thing when people come from different backgrounds and have different approaches to things, and we get stronger when we talk together and we find new ways to approach the same problem. The next thing we do is we try to prevent duplicating mistakes. At Shopify, we like to say that we try to make every mistake unique. But again, when you've got people who are across many floors, many cities, many countries, not everyone is aware of mistakes being made. You're so focused on your own project, you don't always have time to listen to someone else and hear what's going on. So we've found 2 ways to try to correct for this. On a very casual level, in Slack, we're always there chatting with one another. And if someone's having a problem, that's the place to go, and everyone's very generous with their time to jump in and answer. It's very rare that you will jump into a Slack channel, ask a question, and not have an answer within 30 minutes. Someone is gonna be there for you, even if they don't know who you are, even if you're new to the company. That's something that I think is really great about our company. More formally, we are taking our RCAs and we're making a newsletter out of it. We are interviewing the devs involved. We are talking about the incident, we're talking about how we solved it, and we're writing it up in a blog post or magazine style and sharing it across the org. We want to make sure that we've paid the admission, we've paid the price for that mistake, we want as much value for that mistake as possible and to share that lesson as broadly as possible. Next, we try to foster a growth mindset. So this is based off of the work of psychologist Carol Dweck, where she talks about a growth mindset versus a fixed mindset. And a growth mindset is the opportunity to improve, to learn, and to approach mastery. Whereas a fixed mindset says, what I've been given, what I can do right now is all I can ever do. And I don't think that's true of anyone whatsoever. And it's actually sad to me that sometimes we approach life that way. What we want to do at our jobs is to make sure that people can feel vulnerable enough to share their mistakes, be willing to admit it, and be willing to tell other people, because that's how we grow. If we have to hoard and if we're scared that when we share a mistake, that we're going to be judged, that people are going to call us out, that we're going to feel very bad, and that we have to try to, we're going to become quiet because of all the shame, that's not going to help anybody, actually. And we also try to push ourselves to be better at facing that vulnerability. We have people talking at team level show and tells, so you can tell your peers what you're working on and get that feedback. Then we move you to a company-wide talk, so you tell everyone at Shopify what you're working on. And sometimes people have feedback. I mean, I've worked with enough devs. You all are a very opinionated bunch. You will let someone know if something isn't working. And then we move it to conferences. We always say, well, why don't you try telling it at this conference? Why don't you tell it at that conference? To continue to share those stories and then be able to learn from other people as well. Because that's the great thing. If you come to me afterwards and say, I have these improvements for you for your talk, that helps me grow. I appreciate that. I want that. But you have to be at a company that says that that's okay to fail. All right, aid a greater sense of direction. This is all about context. This is all about building an understanding of what we're doing. So again, at the summits, we have State of the Unions, because as we continue to grow, as we continue to get bigger, it can be really hard to understand how your part of what you're doing fits into the greater goal. And when you don't have that, when you're missing that, there's a gap, it can be harder to feel engaged in the work that you do. So it's important to keep telling people what we're doing and why we're doing it. And at the pace that we add people to our company, you can't just do it once and then stop. So this is an argument that I have with devs all the time. They do one engineering talk in our company 2 years ago, and they go, I did it. I don't need to tell anyone else about it ever again. It's recorded. But think of everybody who's joined after you. And if they haven't taken the time to hear that talk, we're missing so much information. And then again, with the newsletters, the reason why we take the time to interview people, why we want to write it magazine style, is because we want to make it as engaging and interesting as possible and have enough details in there that you want to read it. I get so many emails, and so many of them I just send to archive because we are so busy, we don't have time to do it. But I tell my team all the time, we measure everything that we put out, every newsletter that we put out. We say, how many minutes is this going to cost the company? We have 3,000 people at Shopify. If everyone takes 5 minutes to read it, that's 15,000 minutes. That is 250 company hours. Was this one thing that we sent out worth that amount of time? And we are seeing really high open rates for our newsletters, indicating that yes, people agree. All right, number 5, understanding our strengths. There's a really interesting study, and this is something you can do whether or not in a production engineering or within your own life. When people tell the story of their own lives, they actually become more positive about what they're doing. That's a really interesting thing about storytelling, about narrativizing. After this conference, tell yourself the story of how this conference went. What happened? Who did you meet? What did you do? What did you really enjoy? And somehow when we work it into a story, we actually see it more clearly. And this is why I'm such a big believer in stories. Stories are the way that for generations, humans have talked to one another. So we tell stories so that we can underline our strengths. We tell it through blog posts, we tell it through newsletters, we tell it through conference presentations. When we turn our work into stories, we do a better job of actually knowing who we are, why we're doing what we're doing, and what we're good at. All right, the last one is really just a summation of all the other parts. It's an increased connection to work. I think all of us want to approach our work feeling that we bring meaning, that we bring value, that what we do matters, that we're seen. And sometimes, if we're not communicating enough, that doesn't happen. It can feel like we're in a silo. Just having someone appreciate the work that we do or being able to see the response from people is really important. I wish I could give you a metric to tell you how much it matters, but that metric doesn't matter. It's really what's inside here. You can feel it when you connect with the work that you do. So hopefully, by building a culture of communication, you can make a stronger experience for everyone who works in your org. Thank you.
Thank you. So dynamic documentation in 5 minutes, trying to make documentation dynamic and a little bit more fun. So I am Daniel, and I am from LinkedIn. So the problem that we're having is sort of like my problem. I am lazy. So things are hard. I can only do one thing at a time, and I really, really like to copy and paste things. If I have to type it out, I get sad. I would have thought I'd be a better typist by now, but here we are. The other thing is I forget things. There's too much things to know, and I can only keep so many in my head at once. So that is compounded with I look after a lot of different things and I can only do one thing at a time. The things that I look after generally are rather complex, and if it was just a lot of things in complexity, that would be okay, but a lot of the times they're not the same either. So it's a lot of people to tell that I'm lazy and forget things, but oh well. So the other thing is I run a project that gets everyone to make changes to their system, upgrading things, changing latency, fixing latency, fixing monitoring, all that sort of stuff. And I want to make it very easy for people to fix problems. The smaller, more defined problem will get fixed over the larger, undefined one. So documentation is the answer. I want to have written down a solution for every change that I do. For every service that I have, but that would be too many pages, 50,000 pages, can't do that. So now what you're thinking, use that shell style, dollar variable name, then people can substitute it. Or maybe it's shift style, or test style, or the double curly brace, or mustache style, or any other style that you have to updating these wiki pages. Basically, there's too many of them, and I can't copy and paste them. That's not true. I could do something like this, but that only works for things that I can source on the host itself. So we settled on the mustache style. It's fun to say, and it has some other advantages. So having a look at a page, this might seem familiar to you, a little bit of information how to fix a service. And you might notice that we're using that mustache style on that service name there. So it's not too bad, but wouldn't it be nice if we had a templating engine? So I could turn something like service name into the actual service name. So then it would look like this, which is way nicer to look at and a lot easier to read and copy and pastable. So enter AngularJS. So our wiki was missing this feature, has it now. So we go ahead and use query strings, pick that off of the wiki page, but you can't just add a script tag into Confluence. But they do have a HTML tag that you can use. So thanks HTML tag for letting me do a little bit of cross-site scripting and injection. So back to the service page here. So this is all you need to do. That's not true, there's a little bit of other stuff. So basically you pick up everything from the URL bar, rip out the service name and set that to the scope, and now service will get turned into whatever your service is. But we're not stopping there. We've got a lot of information behind a lot of APIs, so wouldn't it be useful if we could have access to that? So let's go ahead and fetch it. So based on the service name, we'll fetch that, grab a bunch of context, update the scope, and now the group becomes the actual group. Or the current on call becomes the current on call. Or who owns the service becomes dynamic. How many hosts they have, what versions they have. Everything that we fix now becomes available in the wiki. So this becomes really easy at 3 o'clock in the morning. We can do more than that. We can show and hide data based on the context that we have. If it's a Java service, hey, watch out for GC, otherwise don't worry about it. We can prompt you for more information. We can use that same system to inject a little bit of an input tag and ask you for some more information. That takes advantage of the two-way binding, so that happens very quickly, instantly. We can use loops, looping over host names to make documentation more pretty. Pretty documentation is red. The other thing we can do is figure out commands. This is an example only, but a little bit of an exercise in what we could do is we could prompt you for putting in fdisk information, and then I could tell you what the command is to fix the problem or to expand a file system. So a bunch of code there. I threw it up on a quick GitHub and GitLab repository, so you can grab that and have a look. So hopefully that gives you a bit of an idea of the things that you can do, only scratching the surface. But the more fun you make documentation, the more people will write it, and then the more people will read it.
Well, hello everyone. So I am an SRE in Demonware. It's basically a game company, but we don't make games. But that's all right. We make the backend for them. And what I'm going to talk here today, don't consider this as a talk, because it's not something super new, something super shiny. It's very basic, actually, and chances are you guys know a lot more than I know. So yeah, resource management and isolation. Everyone uses it every day and like all the time. Nobody cares, but yeah, it's really important all the time. Yeah, first, why do we need this? Like resource management, I have a computer, I want to use it, that's the resource I want to use. Not really. You have many things running at the same time, even if you don't use your computer. So yeah, you have shared servers where many people are using at the same time, and you don't want a single person using everything you have. Like, it's not fair. Or maybe we are providing a service using your hardware for the service, but you have monitoring systems running at the same time, loads of background tasks, backups running all the time, and you don't want to use 100% of your hardware, like running backups and make your customers not happy, not accessing your systems when they need it. And how can I manage resources? There are many ways, actually. Most of them we don't notice because they just happen and we are happy with this. You can embed the resource management inside your application. Yeah, it's fair enough, but it's not easy and it's going to take a long time to make it work well. And we can use virtual machines. That's pretty basic. You have a hypervisor, many virtual machines. You define how much resource, how much memory, how much CPU, how much I/O you want for each virtual machine. It's going to work pretty well. And you have this super cool, mega, solving all the problems of the world containers. Yeah, they work well. Like, especially Docker. Everyone loves Docker. Cool. I'm not saying I don't, but yeah, it happens. So yeah, containers are great. They solve many problems. And I agree with that, truly. For developers, it's amazing. You can run in your machine. You don't need specific service. You don't need to take care of your virtual machines or ask for your sysadmins, SREs, whatever, to take care of your resource. Wonderful. Your application can scale and use 100% of your hardware. Fair enough. It's one of the reasons you use it. You like to use immutable images. I totally agree with you. That's the perfect occasion for using containers, and forget about everything else I'm talking today. You are in the right way. Or you need to scale up and down, like aggressively, all the time, like hundreds of times every single day. You can't do that with virtual machines pretty fast. It's going to take a lot more time, and it's a lot more expensive. And yeah, you guys know a lot more than I know for better applications with containers, because you use a lot more than I use, so there are many reasons to use them. And then, yeah, you have a giant infrastructure running thousands of containers and everything is perfect. And suddenly, you have a 0-day on OpenSSL. Wonderful. What do? You basically recreate 1,000 containers just because you need to change a single library. It works, right? I agree, it works pretty well. Yeah, might be, not sure. But Linux also works pretty well since always. Not just Linux, any kernel use like this kind of features since the age is starting with Solaris. But as most of us are using Linux nowadays, let's focus on the most basic resource management and controlling that's available in all kernels that you are using. It doesn't matter if 4x, 3x, even to 6. You have most Linux distributions with control groups available. It's not a separate thing. It's not a separate service. It's not something magical. It's just there, and you can use it all the time. It's a kernel feature, so yeah, you have it. It's running. You don't need more things. You can label the processes according to the group, so you can have multiple groups in the same machine. You don't need to take care about the disk, virtual machines, containers, whatever. You just label the group to a process it's using. Simple like that. Yeah, the configuration is pretty easy. cgroups v2 is going to make it a lot more easy and a lot more usable, because the version 1 is not so user-friendly. But it's basically a hierarchy, and you just place things inside, create files, folders, and it's going to work. Controllers provide interfaces for most of the resources that you have in your machine. I'm going to talk about them in 1 minute. Yeah, basically you can throttle, limit, make key OS for specific servers that need to have resources when they need. And yeah, they are native. They have native integration with systemd. What does that mean? Yeah, some people hate systemd. I don't, but I use. And yeah, if you hate it, I understand you. But yeah, so basically, you have SysNG running, you just specify your group's resources, and it takes care of the rest for you. I wouldn't say it's so bad. It works. About resource allocation. And then you say, no, but virtual machines isolate everything, or containers are giving me a completely isolated environment from the other processes and everything. What can I do with C groups? All right, you can do the same. You basically isolate services and workloads. You don't have a hypervisor in the middle. Totally fair. So it's not as isolated as a virtual machine is. I agree. You can control your background tasks running. What does that mean? If you have a super busy system and you are taking a backup at the same time or in the middle of the day because you need it, all right, it's going to run. You don't need to make your system unavailable to the customers. It's just limit the amount of resources that your backups can take, or any other operation that's going to be like very expensive for the system. You can have control over asynchronous tasks, like things that run according to something that happens somewhere. And you don't know when it's going to run. It might be a critical time for you, but if you have a limit for that, even if everything is broken and it's consuming 100% of resources for nothing, it's going to work. And it's not going to affect your customers or users or whatever. When you have a shared server or a shared system that many people are using the same piece of hardware, you always will have bad neighbors. You might have the wonderful customers, the best customers ever. One of them is going to use more than the other one, and it's not fair to make the other customer that pays the same not having access to the hardware that he would be, especially for providers like internet services providers, web servers, and these kind of things, shared hosting. It's really useful. You can balance workloads in a single host. What does that mean? Some applications consume more than others, but that doesn't mean that the application that consumes more is more important. Maybe it's not, maybe it's the opposite. And you can control it from the operating system level and don't need to touch the application. It's the optimal solution? No, but it works. And no external dependencies. As I said, it's in the kernel, you can just use, it's available, and it's working. Easy. And you can integrate in your application like natively. So no big deal. You are writing a new app. You don't need to write the controllers, worry about many things. You can just use the APIs that the kernel provides, and it's going to happen according to the operating system, and you have all the data you need. So basically, like, I resume, use the right tool for the right thing. Containers are good, of course they are. But if you just know containers, of course you're going to use containers for everything. So take some time, research something, see how things work. I don't like virtual machines, all right? I don't like containers, cool. I don't like C groups, perfect. You have mesos, you have many other options. You don't need to use just a single tool. Get the best tool for the right job, make it happen. You learn something new at least. And yeah, that's it. That's the content. Use the right tool for the right job.
All right, so I'm Guy. I'm CTO at SignifAI, and I'm here to talk about something that pretty much we all care about, and that's metrics and monitoring and collecting all of that. So I'm going to talk about Snap and a little bit about the framework and what it is trying to solve and what we are all trying to achieve, actually. So first of all, you know, it's pretty jungle out there. There are a lot of different metrics to collect, different types of tools, different types of frameworks, and it's pretty crowded. You know, it's not trivial. What is the right way to do that? There are a bunch of things like too many tools, things related to different formatting, how I will take one format and convert that, how do I collect the right thing for me? Different needs, you know. So some metrics you need to collect on all the time. Some metrics you need to collect based on a schedule. It's pretty complex. How do you make those differences? And then in today's reality, you know, we all have things that are SaaS-based, public cloud, private cloud, things that you need to collect from the machine. So what if I need to collect something internally from the operating system, but at the same time I need to collect something remotely? You know, can I do that with the same tool? And obviously, that's pretty complex. So, you know, even within the operating system, you have different types of subset tools in the operating system that you can use and you collect data from. So that's pretty complex. And usually what I've found is that all of us are starting to customize our collection, whether it's like CollectD or StatsD or Elastic Beats or whatever it is. You know, you start to add more scripts around it and you kind of tune it and you do all of that because you want to really try and fetch different types of metrics and information. And the other question is like, how do you scale that from a single instance to 1,000 instances? How do you actually start to replicate that configuration? And how do you make it scalable? Not just in terms of the collection itself and the configuration itself, but can you even create something like a cluster of collection? You know, so that's pretty challenging. And the last point that I always like to make is, what if we could do, or if we can create a collection much smarter? So wouldn't it be great that you're not just collecting the metrics, but start to put some intelligence in terms of processing it before you ship it to the backend? So that would be great. So all of those issues that I've been thinking about, you know, I think that's one of the challenges that we're all facing with the current tools. So it's kind of scary, you know, and what should I collect, and how should I do it? So, you know, my kind of theory is like, you should just collect them all, right, and how you do it. So there is Snap. So Snap is an open telemetry framework. It is backed by Intel, but it is completely open source, Apache v2. And it's really powerful. It's really great. So it's written in Go, and it's really about simplification of how you manage telemetry. And you have different types of layers in the framework. So you can basically control the collection separately from processing, separately from publishing, which allows you full flexibility. It is fully compatible with its own internal API, so it's all REST-based. You can control that directly. And the nice thing about Snap is that it provides the support of clustering. So now you can actually create a cluster out of your collectors, and it's really powerful in terms of scalability. It's also powerful in terms of how much power you can put into the collection itself. And everything is pluggable. So it's completely a decoupled model between collection, processing, and publishing. So here's how it works. So Snap workflow is kind of a pipeline, if you want to think about it that way. So you can collect, and you can collect from different types of collectors. So you have a plugin for every single collector. You can collect it locally from the operating system itself. You can also collect remotely and bring that data in. And then you have something called Processor, which is another plugin, which you can filter, you can decorate, you can enrich, you can transform, you can do all those manipulations before you even ship that into your backend. And then you have the publisher, which supports multiple backends. So it can be a file, it can be Elasticsearch, can be time series database, can be any type of analytical framework. And the nice thing about it is that you can push to multiple backends. So you can define, hey, I want that specific metric go to my Elasticsearch, and at the same time, I want the same metric, maybe with a little bit of processing, to go into my Kafka, for instance. And you don't need to write any customization or any script. It's part of the pipeline. So over 100 plugins available today. It's pretty awesome that you can find almost anything that you wish already out there. And if you can't find it, it's pretty simple to write one. I'll talk about it a little bit later. Then the really important part is the middle, the processing part. Because if you think about it, and I've started to talk about, wouldn't it be great to put some logic into the collection? And that's actually right there. So you can set up anomaly detection right there in the collection, right? So, and you can push only the anomaly metrics to a specific backend while pushing the original metric to a different backend. So you can have that kind of flexibility. It's really powerful. So things like Grafana goes on top, your Graphite cluster, or anything at all that you want to, any other framework that you want to use, you can use with a publisher. So if there's only one thing you need to kind of come out of this talk is like three sets of plugins: collectors, processors, publishers. The other interesting thing about this framework is it supports flexible scheduling. And what that means is that you don't need to just collect every time. You set your collection interval in advance. You can set up different types of tasks in Snap. Every task will have its own schedule. So you can have it scheduled as a cron. You can set it based on time. You can set it continuously. It supports streaming. So again, think pipeline. And you have full control on tasks and scheduling. So it's pretty powerful. Another great thing is dynamic control. So what that means, as opposed to other framework and tools that are available out there, is that when you want to make a change, you don't need to restart the process. And that means that no restart to a process means zero downtime, because you're not losing collection. So you can update your plugins in real time. You can add a plugin. You can swap a plugin. You can change a metric configuration, add a processor, and just reload. And it's all taken care of as part of the framework. So it's pretty powerful. I want to give you an example into something we've wrote that wasn't available, and that's a Nagios plugin, right? So think about it. What if I want to take, there's a lot of discussion about the difference between events and metrics and logs. Snap supports it all. So you can take a log file and create a metric out of it. You can create an event and or take an event and enrich your metrics. So that's really powerful for anomaly detection, for instance. So Nagios plugin, basically listening to status.dat file, process that, and then run a processor to dedupe the lines, and basically adding tag filtering to tag-specific checks, and then stream that to the backend. So extremely powerful. There are multiple regex plugins available out there, and we wrote also our own. So that's just an example of what you can do with Snap and why is it powerful. Last, scaling. So tribe is the concept in Snap that is basically introducing a clustering into the telemetry framework. It means that now you can have a single change in your plugin or your telemetry framework, and just from a single node, transmit that change to all your tribes. So think about 1,000 nodes, and you just go with Snap CLI into one of them, make the change, it distributes to 1,000 nodes instantaneously. It's run as with basically it's masterless, all gossip protocol. So changes are basically introduced instantly. So main advantages to sum up, it's pretty flexible, super maintainable, ready and go, high performance, super secure because you can secure the communication over TLS, and flexible scheduling, and all of the other advantages that I've noted. And last, go here, write plugins, support multiple languages. Thank you very much.
Hey, everybody. Thanks for coming to my lightning talk titled Decentralized Data. My name's Jason Koppe, and I'm an SRE at Indeed. I originally joined Indeed as a system administrator, and recently my team of system administrators joined the SRE organization. Me and my team have worked on this decentralized data system since the beginning, so I'm just going to share some of our experiences. For those of you who are unfamiliar with Indeed, our mission is to help people get jobs. Our primary product is a job search engine, and that product takes advantage of this system. Quick agenda for the talk. First, I want to give a brief overview of the system. Then I'd like to talk about the toil and outages that we've experienced over the years, and wrap up with some of the improvements and lessons that we learned along the way. So at a high level, what I'm talking about when I'd say decentralized data is Indeed needed a Lucene search index to power our search engine. And in the early days, we wanted a way to scale the search engine independently from our database. And so we came up with this concept of decentralized data, where we would have a Lucene index builder write the data to the file system, and then use rsync to ship that data to our application servers, which we could scale independently. And those application servers would access the data that's on the file system and serve the requests. I'm not going to go into all the details about the system. My colleague and I, Julie Scully, talked about this before. So you can find this talk online, how we replicate terabytes of data around the world every day, to learn more about how it works. But I do want to go into some of the toil and outages that we had over the years. So first, the system administration team created this system, the data replication system. And so we were the only people in the company, the centralized system administration team, that managed the stack. And this meant that for any new data artifact that a development team wanted to add into the system, they had to come to the centralized team and ask them to configure replication. And this was okay in the early days, but as the company grew, the system administration team wasn't growing as fast as the development team, and caused some slowdowns in getting some data replicated in the system. One of the common outages that we had was a server crash. So you can imagine that we'd have a producer running right now, and in the middle of flushing to disk, the server crashes, and we go to restart the server, and when the server starts back up, the producer tries to resume updating the data, but the data is corrupted, so the producer fails. And in the early days, we manually replaced that data with some known good data. Another common outage was a network disconnection, and this could be between individual servers or in between data centers. So one common problem that happened is there would be a packet loss between two of our data centers, or a complete disconnect between two of our data centers. And in this situation, data center 2 was unable to get fresh data. So as a workaround in that situation, we would log in and manually reconfigure the replication path to go through data center 3. And another really common outage that we had was exhausting our network I/O. As we added more and more consumers, the network I/O on the producer server was becoming overloaded. And one of the ways that we got around that was creating what we call a staging tier. So we'd have staging tier servers that would download from the producer server, and then the consumers would download from the staging tier, thus allowing us to have more total network I/O. Another outage that we had was a cascading out of memory during a data reload. So if you imagine that we have a cluster of servers running this application, running our search engine, and they're loading this data artifact version 1. During steady state, we're using about 65% of the JVM heap, and when we go to reload the data, we're using like 95% of the heap. Maybe this is okay, and once we finish loading that version, we can stabilize back at 65%. But the next time we load artifact 3, some percentage of the cluster starts using 100% of its heap, and those instances become unavailable. The remaining parts of the cluster get more requests, and they quickly fall over as well. So this led to a total cluster outage when we were reloading our Lucene search index. So the way that we got around this in that post-mortem was, of course, restarting the cluster, increasing the heap, but we kept part of the cluster having a smaller heap size, expecting that if there was another large data artifact that would come in 3 months or 6 months, that instance would trip and run out of memory first, but we'd still save the cluster. Another outage that we had is we replicated corruption. So the situation was this: the producer file system filled up, there was a bug in the publishing code that allowed a corrupted artifact to be published into the replication system. So it was replicated to all of the servers, and all of the consumers on those servers tried to load this data artifact, but failed because it was corrupted, so they failed their health checks. Great. Then the load balancer took all of those instances out of rotation, and we served an empty page. And this was a total Indeed.com site-wide outage across all of our data centers. So naturally, we wanted some improvements to this whole system, and we started off to create a next-generation system, which we called Reliable Artifact Distribution, or RAD for short. The first thing that we did is we wanted to replace the point-to-point rsync, and we did that with BitTorrent. This allowed for a lot more horizontal scalability on the producer server's network, and it also allowed us to kind of automatically have data transfer around these point-to-point data center disconnections. We also wanted the system administration team, now the SRE team, to scale sublinearly to the way that the developers were going. So we made sure that the devs could declare producers and consumers in their code so that the replication system could automatically be configured. And this allowed for developers to add data into the system without needing to come to the system administration team. The next thing we wanted to improve was the Canary data reload. So when we had the custom heap size, that was a custom heap size per cluster, per region, per service, and so it just wasn't really sustainable to have all these custom values. So we looked at using console to coordinate the data reload across the cluster. So you can imagine that there's a new version of data available. One instance in the cluster gets a lock and says, hey, I'm going to load this next version of data first. Everybody else just hold on. And once that instance says that it's okay and healthy, the remaining parts of the cluster load that next version as well. Another one of my colleagues, Ann Kilzer, gave a talk about this at Velocity earlier this year, titled Canary in a Coal Mine, so you can find out more about that online. So overall, there are some lessons that we learned through all of this experience. Number one, if you're updating data, always resume from known good data. Your servers are going to crash, and so resuming from known good data is a way to work around that. If you're ever writing to the file system, look into atomic file system operations, because again, these are going to help with crash recovery. The concept of canary is pretty common in release engineering, and it took years of experience for us to realize that having a canary for our data reload was really valuable as well. Use BitTorrent, and build self-service system that your entire engineering organization can use for organizational scalability. That's it. Thanks.
My name is Emil. I work at Shopify, and today I'm going to be talking about how Shopify does failovers. Well, really what I want to show off is recently Shopify has hit a new level of automation in our failovers, and I want to sort of demo it and give everybody some ideas about how they can sort of approach failovers. So to give you some history and context, Shopify runs in multiple data centers, and it has multiple shards in each data center, and it runs in an active passive capacity. So what that means is if we have issues in a single data center, we have to consciously fail over the shard from one data center to another. And before, what this would look like is we'd have a bunch of engineers gather at the office at 6 in the morning when traffic is at its lowest and fail over the pod, going through a checklist and monitoring, looking at monitors and dashboards, hoping that everything works as it should. Recently, we've actually integrated this into our ChatOps tool. So if you've seen Daniela's talk earlier today, this is our internal ChatOps tool, and now you can run an entire failover from Slack. So as you saw earlier, we have an authentication portion in our ChatOps tool to ensure that not everybody can run our failovers through Slack, because failovers are inherently complicated. And so what's going on during this failover is we pause our requests in our load balancer layer to prevent 500s from occurring. We'll set our MySQL shard in the source data center to be read-only. We'll wait for replication to catch up in the target data center. We'll then flip over to the new data center and turn on the writer there. At the same time, in our service discovery tooling, we will inform or swap the value of what data center that particular shard lives in. And we'll have to do a reload across our load balancers. So when new requests hit our load balancers, they get rerouted to the correct data center. And so right now, this final step, which is the longest step in the entire process, is actually transferring jobs from one data center to the other. And takes about a minute and a half. Right. So as you can see, while that's happening, this is actually integrated into our Shipit deployment tool. Shipit is what we use for automating our deploys. And so the benefit of having and using Shipit is that, and I believe we're almost done. Yep, there we go. So it took about a minute and a half for us to fail over from one data center to another. So like I was saying, with Shipit, we're able to sort of integrate into that same automation and tooling we had before, where we can lock Shopify or lock the particular failover capacity and give sort of information to our SREs about why we locked it. And so we like to dog food our own product at Shopify, and we decided to have the youngest intern on the team do the failover recently. This is a picture of him just after he completed the failover. This is actually our coworker's, one of the coworkers' son. He's 3 years old. But it's one of those things where we like to think of the tooling we develop at Shopify to be simple enough that a 3-year-old could use it. So unfortunately, we're not hiring 3-year-olds. But if you're interested in working this kind of stuff, a bunch of us will be out by the booth and near the reception. Come by, ask about how this works. Thanks.